Hello everyone, my name is Engineer Angad Singh Kalsi and welcome to my YouTube channel. So guys, here we are starting with the lecture series of engineering graphics, and this is the lecture 1 which is about the basics. So what is a art? Now, all of you might be wondering why we are discussing art in an engineering lecture in the first place. But art is a crucial aspect in the engineering graphics as well. So, art is a way for people to express their ideas, imaginations, and feeling through drawings, shapes, colors, design. There are many forms of art, but here we look at two main types, which is the abstract art and the parametric art. Abstract art is a free and creative art form. It does not follow strict rules or measurements. It's open to imagination and different meanings. On the other hand, the parametric art is the art that follows the rules and parameters. Every point, line, or curve is made with logic, numbers, and clear relations. Because of this, parametric art can be repeated, scaled, and used for practical purposes. This is why parametric art is the foundation of engineering graphics. Now, what is engineering graphics? So, engineering graphics is a branch of engineering that deals with mechanical design. It helps in redesigning parts better and creates clear practical drawings of machine elements for a system by following defined rules and constraints. It's the art of parametric visualization. Engineering graphics inculcates three domains in an engineer, which is re-engineering, engineering of a part, and the art of visualization of the product. For example, its material and its appearance in a FreeCAD software according to machine element specifics. So here in front of us is an isometric view of a part which was made on AutoCAD software. The part was made using the AutoCAD software according to the dimensions which were provided in the drawing. The second photo describes is how the part was to be visualized in the spatial space with the materials which were supposed to be used in developing the prototype of the part, and then how the colors will look like in the environment. Everything is visualized in front of us using the visualization tools within the AutoCAD software. Now the third photo gives us a view of the cross section of this part. We can create this profile and then we can use the revolve tool around the axis to make this part come to life. So now within the engineering of a part, an engineer learns about the cross sections, the tolerances, the measurements and the standards like the ANSI, the ISO and DIN standard that ensure the correct fit in assemblies. For example, if we take a nut and bolt system over here, the bolt has a head, shank and threads, while the nut has matching internal threads. Standards define dimensions like diameter, pitch, and proportions. So any standard nut fits a standard bolt, ensuring interchangeability, manufacturability, and reliability. Now let's move to whiteboard for further practical explanation.
So hello everyone, we are back on our board, drawing board. Okay. So as we were discussing about the engineering
Graphics
graphics.
101, and this is the practical session. Okay, so in here we are going to discuss what are the tools within the engineering graphics. So we will talk about the line tool first and the concept of control points. So here we are having three control points, P1, P2 and P3, and here we have put the P2 in between the P1 P3 as midpoint. So the P1 and P2 is making one line and P2 and P3 is making another line. So these two are the line segments. So now when we talk about the arc tool over here, so we have two control points over here, point 1 and point 2, and in these 2 points there is a radius of curvature upwards which is of the radius 20, and it is basically our arc. If we make it below of the same radius of curvature, if we make between these two control points arc, it will form a circle. So now talking about the 3 point arc, we can also make an arc with the 3 points. For suppose if we put 3 points like this, and if we basically make a radius of curvature between P1 and P2 of radius 20, and also between P2 and P3 of radius 20, we will get this radius of curvature between P1 and P3 as same radius 20. Now, if we talk about curves, we have something called as Bezier curves, which are the complex curves. So if we have a lot of control points arranged like this, around 10 control points, and if we join them, we'll obtain a complex curve with varying radius of curvatures. So the radius of curvature between control point 9 and 10 and 4 and 5 would differ in the radius of curvature. So this is a complex Bezier curve. Now, if we have look over the constraints, so this is the ortho constraint, that we are able to draw a line in horizontal and vertical axes between 90 degrees, as you can see. Okay, so in here there is another constant, that if we define any angle, so here if we define 45 degrees, we'll be only able to draw the line at 45 degree. And now we will talk about the other things like your chamfer and fillet. So in chamfer, basically we define the two distances and of the rectangular element. So on the basis of that, we are able to create line. So if this is the rectangular element, for suppose, and like this, okay, this is one of the corner. The corner would be chopped off, and it would be replaced by this at 45 degrees, right, from the edge. So this would basically mean this is chamfered. And in fillet, basically in the rectangular element we are creating curves. Okay, so this is about the chamfer and the fillet. This is difference, and these all things are applied in the engineering graphics for creating the parts drawings. Now we will move on to the computer for more explanation on other topics. Okay, so now we will talk about the types of lines that are used in the engineering drawing. So as you can see from the table, in engineering drawing, different lines show different meanings. The continuous thick lines mark visible edges, while the continuous thin lines are used for the dimensions and guides. Dashed lines represent the hidden parts that are not seen in the view. The chain thin long short shows centers or symmetry, and the chain thick long double short marks cutting planes. Freehand continuous lines show the short irregular breaks, and the zigzag lines indicate the long breaks in the objects. Now moving forward, here we can see the cross-sectional view, which is obtained by using the cutting planes. So as we can see in these three drawings, that the cross section of an object is visible onto the paper when we cut the object using a cutting plane. The cutting plane is labeled with letters like AA or BB. Those letters tell us which section view matches the cutting plane. In the second drawing, we can see that there is a green part in front of us. In that green part, we can see that a section AA has been created, which is the cutting plane, in which there is a hole in a part. So there are different holes which are there in this part, and we can see that how it looks from the section view. Talking about the third part, in the third part, there is one circular hole we can see in the section view. So we should have a habit of creating the cross sectional view for better visualization of the part, so we can understand the drawings clearly. So what is the orthographic projection? So orthographic projection is nothing but a method of representing a 3D object on the 2D plane using multiple views such as front view, top view, side view. Each view shows the object from a specific direction at a right angles, allowing engineers to describe the exact shape, size, and dimensions of the object clearly and accurately. So as you can see in the left, we have an isometric view of the part, and the front, side, and the top views are the projections, which is the first angle projection which has been drawn on the basis of the isometric view which was given to us of the part. Now we will move on to the drawing board to create orthographic first angle projection of a part. Basically, this is the isometric view of the part. Okay, very quick. I'll be very quick here. This is front view, this is side view, typically left, and this is the top view. Now I'll be very quick over here. 1 mm is equals to 1 centimeter. This was our way of representation. These are projection lines. Thanks for watching my video lecture. If you liked my video, don't forget to share with all of your friends, and don't forget to subscribe to my channel. Till then, I would be uploading more lecture videos. Thank you.